Hello everyone, welcome to this lecture. So till the last lecture we saw how we can use the Ethereum network and how we can connect to the Ethereum test networks and do some queries and transactions. But in this lecture we will see that how we can write some smart contracts. So we will see how to write Ethereum smart contracts and how Ethereum smart contracts are executed through the EVM, which is Ethereum virtual machine. So we will be writing the contracts in a specific language called the Solidity language, and then we will see how we can deploy these smart contracts in a test network and execute them. So the keywords for this lecture are Ethereum smart contracts, the Ethereum virtual machine or EVM, and the Solidity language. So what are smart contracts? So smart contracts are basically programs which are executed in a decentralized setting, and these programs actually work on whatever data there is in the distributed ledger. So they can read data from the ledger as well as write it back to this ledger. So the output of any such program, any smart contract, depends on the consensus of the independent participants executing it. So it is not like our traditional programs which are executed in a single system, in a single process. These smart contracts instead are executed independently by the different participants of the blockchain network, and the successful execution of a smart contract depends on the consensus of these participants. So in Ethereum network specifically, the smart contracts are programs which read data from the Ethereum ledger, and they can do some operations on this particular data and then write it back to the ledger. So the results will be committed back to the Ethereum ledger data. Now these smart contracts of Ethereum networks have some specific properties. So these contracts also act like individual accounts. So whenever a smart contract is deployed in the Ethereum network, then it gets its own address. So it will have its own account. Therefore the contract itself can have a balance, and it can also do transactions. So the smart contract can send transactions over the network, and these contracts are not at all controlled by a single user. Instead they are run by whatever logic is defined in that particular contract. So the user accounts interact with these smart contracts by submitting transactions that execute a function defined on the smart contract. So in one particular contract we can define multiple functions. So it can be doing multiple operations, and whatever operation we need to execute in a smart contract, they will be defined as these functions, and we will be sending transactions specifying those functions. So we will see this in detail. Now how these smart contracts are actually executed in the Ethereum system. So the Ethereum network implements a distributed state machine or a replicated state machine. So the Ethereum ledger actually is holding the state, and any transaction that we do in the Ethereum network changes that state. Okay. So these smart contracts are actually programs which changes the Ethereum ledger state from one state to another. So the Ethereum data holds the account balances and many other parameters. Apart from that, the smart contracts can also define their own variables, so state variables, and depending upon the execution of the smart contract, those variables can be changed with one transaction to another. So another important point is that these state changes must be deterministic, because remember, unlike traditional programs, these smart contracts are not being executed by one process. Instead they are being executed independently by multiple participants of the blockchain network. So therefore if the execution of a contract is not deterministic, then the result of that execution might be varying across different participants. Okay. So therefore consensus will be a problem in that case. So if one participant is getting one output and the other participants are getting some different output, then they won't be able to reach consensus. So, whatever state is being produced or whatever results are being produced by one smart contract execution, it must be same across all the participants executing it. And so, each smart contract must have deterministic logic. So, we will see the flow through which in Ethereum smart contracts are developed and compiled and executed. So, firstly we have the smart contract code, and this code can be written in different languages. The most popular ones are Solidity and Viper. So, these are the two most popular languages in which you can develop Ethereum smart contracts. Now, these smart contracts smart contract languages are high level languages, and they cannot be directly executed on the Ethereum virtual machine. So, what we need is a smart contract compiler. This specific smart contract compiler takes input the high level smart contract code and produces the output as byte code. So, this contract in high level language is converted into byte code, which then can be executed by the Ethereum virtual machine. Okay. So, in the images you can see that the Solidity on the left, you can see the smart contract in Solidity language, and then after compilation it is turned into some kind of byte code which is executable by the EVM, but which it is difficult to understand for humans. Now, this byte code can be deployed as a smart contract in the Ethereum network. So, you can deploy this byte code in any specific network such as the Ethereum main network or any test network of your choice. So, at this point once this contract is deployed, you remember that it would be getting its own account and therefore, its own address. So, now since the smart contract is deployed and it is there in the Ethereum data, the ledger itself, it can be accessed through that account address of the contract, fine. But how do we actually execute it? So, we need a way to execute it. This contract is defined as a byte code, hence it would be very difficult to actually execute the individual functions which are defined inside it. So, for that reason what we need is an application binary interface or ABI. So, the Solidity compiler and the Viper compiler, so the smart contracts compilers actually produce this ABI alongside the byte code. What this ABI does is it defines the different functions which are there in the smart contract code, and then using this ABI these functions can be executed through the Web3.js library, fine. So, then this Web3.js library will take the ABI as input and also the smart contract address as input. So, and combining this we can execute the smart contracts which are deployed in a specific network. So, let us learn more about one language which is Solidity. So, Solidity is the most popular language which is used for developing Ethereum smart contracts. So, it is a high level language for implementing smart contracts, and it is statically typed supporting inheritance, and it also supports libraries and complex user defined types. The syntax is actually pretty simple and it is influenced by JavaScript and C++. So, on the code snippet on the right you can see that a contract is first defined as with the keyword contract and then simple storage. So, this is the name of the contract, it can be any name that you want to give it, and then it is followed by some state variables and then some functions. So, these functions are the way of executing the smart contract. So, whenever we want to execute a contract, then we need to specify which function we need to execute. So, we will see in more detail what this code means, and we will also try to run this contract and see the output. But before that we will learn more about the different compilers which are available, fine. So, Solidity is the most popular language, and for compiling Solidity we have the Sol compiler or SOLC. So, this is a command line tool which can be used to convert Solidity program files into bytecodes. And apart from the usual compiler, we also have a very popular editor, a code editor, which is a Remix editor, which is browser based also. So, it is really easy to use. We will see how we can use Remix editor to edit some Solidity codes, and also it includes a Solidity compiler in itself. So, within the Remix editor, we can write our code, compile it, as well as test it and deploy it. Okay, so let us go through one very simple smart contract, which is for storing one variable on the Ethereum ledger and then later retrieving it. So, the first line is actually one comment which says the license of this particular contract, because when this contract will be deployed, then this will be important. Okay. And then in the next line we specify the pragma solidity, the version range that this contract will be supporting. So, we are defining the minimum version of the compiler and the maximum version of the compiler that this code will comply to. Okay. And this from the next line, the actual definition of the contract begins. So, first keyword is contract, and then the name of the contract is storage, and then inside that we define two functions and one variable. The variable is of type unsigned int 256 and the name is positive number. So, we will be using this variable to store some data on the ledger. So, whatever we save, whatever value we save to this positive number variable, it will be committed to the ledger. So, for doing that, for changing the value of this variable, we use one function called store. So, function space store. So, it takes one input, so which is of the same time unsigned into 56, and then we define it as public. So, what public means is it can be executed from outside the contract. So, by users, it can be executed. If it is not public, then this function will be accessible only through other functions which are defined within this contract. Since it is public, this function can be used for doing transactions. Okay. Then the actual function definition has only one line, which is assigning the value given as input to this variable positive number. So, this is for storing the input given by users, and then the next function is for retrieving the same input. Okay. So, we have a read data, which is also set as public, it does not take any argument as input, and then we have another keyword which is called view. So, view means a function which does not write any data to the ledger. So, view means it is only querying the data. So, this is very important because in Ethereum, of course, there is a fundamental difference between queries and transactions which change the ledger data. Queries are free, basically you can download the ledger data and query the state from it, but doing transactions require gas. So, this transaction for any function which is not a view, you would need to do a transaction, and that would require some transaction fees as gas. But reading data, so the functions which are marked as views do not require any gas, and this particular function returns a variable of type unsigned int 256. So, and inside the definition we see that there is only one line, return positive number. So, to begin developing smart contracts, we will be using two tools. One is the Remix editor and another one is the MetaMask. So, here we will be installing one particular browser extension which is called MetaMask. This will be useful in accessing the Ethereum network from the browser itself. So, when we will be using the Remix editor, then through MetaMask, Remix will be able to connect to the Ethereum network. So, here we will just go ahead and install the Chrome extension for MetaMask. It is as simple as pressing the download button and adding it as an extension. So, it will take some time to download, and then we can see now it is added as an extension. So, when you run MetaMask for the first time, it will ask you to either import an account or to create a new wallet. So, we will go ahead and create a new wallet. So, we would follow the instructions given and we would need to set a password. So, you set your own password, and after doing this, the MetaMask will create a new wallet for you, and that wallet will include one Ethereum account. Okay. So, we can see that we have one Ethereum account created, and we can use this account from MetaMask across all different networks, main network, test networks. So, in the Goerli network, we see that the actual balance is shown as 0. So, we do not have any ethers in that particular account. So, what we can do is we can add some balance there. So, once you add some balance from either the Goerli faucet or some other account, then the balance will appear within this MetaMask. So, in the main network we can see the balance is 0, but in the Goerli test network we see that we have 2 ether balance. So, this balance will be required for making transactions later. Now, we will see how we can use the remix editor to write some smart contracts and compile them and deploy them. So, first you can open the remix editor from your browser from this URL, and once this editor opens up, you can see that there are some files which are already present there, and there is one workspace created which is called default workspace. So, what you can do is you can go ahead and create a new workspace for yourself and start writing a new Solidity file. So, let us name our workspace new workspace and save that, and then we will go ahead and create a new Solidity file after selecting that new workspace. So, we will click the new file icon, and then we will name our Solidity file with an extension .sol. So, now we can write our smart contract code here. So, we will be writing the smart contract code of the simple storage contract. So, the first line will specify the range of the compiler versions that this code will comply to. So, it should be greater than or equal to a minimum version number and less than a maximum compiler version number that it supports. Next, we will be defining the actual contract. So, contract space the name of the smart contract, which is storage. Then inside that we will specify only one variable which will be used to store a value on the ledger. So, it is unsigned 256 typed, and the name of the variable is positive number. Next, we have to define two functions. The first function is store, which will be taking an input unsigned integer, and then it will be assigning it to the positive number variable. So, it is a public function, so that it is executable from outside the contract. So, users can basically do transactions to execute this. And then the next function would be to read this data. So, this will be a public function, but it will be also a view. So, it will not be changing any data from the ledger. It will only read this positive number variable from the latest ledger state and then return this. So, it returns an unsigned integer and return positive number. So, at this point the contract is ready. So, now what you can do is you can go to the compiler block and you can hit this compile button. So, this remix editor will compile your Solidity code. So, if you have any errors, it will also show you, like we are getting one warning that the license is actually not specified there, which might create some problem when we try to deploy the contract. So, we have specified the license also as GPL3. Now, if you execute it, then we can see the contract execution is successful. So, this particular compiler is outputting two specific things as we discussed. The first one is bytecode and the second one is ABI. So, you can click on this ABI button to copy it, and if you paste it in a text editor, you will see that it is outputting different things which defines the different functions which we wrote in the smart contract. You can see the two function names as well as the parameters they take as input. So these are the two functions. The first one you can see is read data, and it does not take any input. The second one is writing the data, which is store, and it takes input the unsigned integer input number. So using this ABI would be required in the later stage when we try to execute the smart contract from Web3.js. Okay. So the other output is of course the byte code, which will be ultimately deployed in the Ethereum network. So this is the specific machine code, or basically the code which is understood by the EVM, the Ethereum virtual machine, and this is the byte code which will be deployed. So once you can compile your smart contract, you can actually test it from within the Remix editor. So what you can do is you can go to deploy and run transaction and select this JavaScript VM, and the version is London, and then click on the deploy button. So what it will do is it will deploy this particular smart contract within this JavaScript VM, that is an emulator running within your browser. So it is not being deployed in any specific network, but it is being deployed on this particular emulator. Then you will be able to see this deployed contract on the left hand side here, and you will be able to see the two functions also that we defined, store and read data. Store is taking some input, so let us give it some input 22 and then click transact or execute. So you will see that you will see a green tick if there is no error, and it will also show you the encoded input that it is taking. And if you click on read data, you will be able to see that it is producing that same output that we gave during the first step. And if we give it some different input, then store, and then read will produce a different output also. So once the emulation is successful, what you can do is you can try to actually deploy it in a particular network. So if you select injected Web3, it will open up the MetaMask extension. Fine. So in the MetaMask extension, you can select which account you want to do the transaction, and you can also select the particular network you want to use, the main network or the test network. So you can see that in below injected Web3, it is showing me the account and also the balance. So in MetaMask, in Goerli we have 2 Ethereum, but selecting the main network we see we have 0, and whenever we change the network, it is also being changed in the Remix editor. So we will change it back to Goerli test network. Fine. So we have some ethers there to make some transactions, and we will use this deploy button to deploy it. And when you click this deploy button, MetaMask extension will come up. It will show you an estimate of how much ether it is going to spend for this particular transaction as gas fees. So if you click on this confirm button, it will send the transaction to deploy this particular contract on the Goerli test network. So this time we are deploying the contract in the real network instead of this emulator. Okay. So we saw that the balance is reduced a bit from 2 Ethereum to less than that. So if we click on this particular arrow, you will go to Etherscan, where we can see that the details of this particular transaction where the smart contract is being deployed. Fine. So now using this deployed contract on the Goerli network, we can also do the similar kind of transaction. So if you see the deployed contract, we can give it some input to store, but if we click on transact, then it will open up MetaMask again. Why? Because doing a stored transaction means writing something to the ledger. So it is basically one transaction. So click confirm, and it will submit the transaction for storing this variable into the Goerli network. So you can go back to Etherscan to check if that transaction is executing correctly or not. So it will take some time to execute. So this is for storing that variable. So once it is successful, you can go back to the Remix editor, and then you can see if read data works. So if you click read data, then of course it won't be a new transaction because it is just a view. So it is reading the latest data from the ledger state. Okay, so we saw how to write a smart contract, test it from the remix editor as well as deploy it in a test network. Now we can also use this Web3 library to interact with these deployed smart contracts programmatically. So this is very important for developing decentralized applications or dApps. So you have several smart contracts already deployed in the Ethereum network, be it the main network or test networks. So if you want to use those smart contracts from a dApp, then you would need to use the ABI as well as the address of the smart contract in the Web3.js library. Okay. So this sample code basically shows you how you can use Web3.js to define a smart contract which is already deployed on the network and then execute functions on it. So here the first lines is actually importing Web3.js library and also Web3 Ethereum contract, and then we will be setting the provider, which is the Go Ethereum client's endpoint that is listening for RPC over HTTP requests, as we discussed in the last lecture. Then we will be defining the contract. Now the contract definition has it takes input the ABI, which is very important. So you need to provide the ABI of the smart contract that is deployed. Without this ABI, it cannot execute the contract functions. And apart from the ABI, the second argument is basically the address of the deployed smart contract. So this is the address of the contract. And the third argument says that from which account will the transactions be sent to the contract. So basically this is your account or whatever account the dApp is using, and a gas price. So this gas price can be set according to the gas price which is or the average gas price in which the transactions are being executed in the Ethereum network. So to execute this contract, we need to specify which function we need to call within the contract. So my contract, that is defined here, dot methods dot the name of the function. Okay. Now if the function name is read data, then this is basically a view. Then for a view we would do a call. So call means it won't be sending any transaction to the ledger. Instead what it will do is it will just read the latest ledger state and find out what data it needs to read for read data and give that as the output. So to print the output, we can specify dot then and then pass the function console.log. Okay. So similarly, this is for reading data. Now what if you want to also execute store, for which writes one integer back to the ledger. So for that only one part will change. So this is the code for executing store. You can see that the rest of the code is same. The contract is being defined with the help of the ABI and the deployed contract address, and my contract dot methods dot store function is used. So this store function will be called and it takes one argument also. So we are giving this argument 11 as input, and then instead of call we are doing a dot send. So this dot send is required for functions which are not defined as views. So these functions will need to execute some transaction, send some signed transaction, and that will require gas. So this my contracts dot method dot store function takes input this number 11, which will be stored back to the ledger, and since it is editing the or storing back some data to the ledger, we would need to specify send. So in contrast to the call, we just read some data, send will be writing the data back to the ledger. Then we do a dot then and console.log. Okay, so we will see how we can use these codes to read and write some data through smart contracts. So to do any kind of interaction through Web3, we must first ensure that Go Ethereum client is running with one account unlocked. So let us use Web3 to write this particular function or program which will be used to query the contract. So first we will be importing the required libraries, which is Web3 and also the Web3 Ethereum contract. Then we will define our smart contract, which is already deployed using using the ABI. But before that, let us also fix the provider, because this Web3.js library needs to interact with the Go Ethereum client, and that is running on port 8545. So we have set the provider to HTTP provider port 8545 localhost. So after this, we are defining this contract as var my contract equal to new contract, and then we would need to pass the ABI here. So what you can do is you can pass the ABI here directly by pasting it from the Remix editor. So apart from the ABI, we would need the contract address and also a from and a gas. So we would define those later. Let us take the ABI first, go to the Remix editor and then click on this compiler, and there you can copy the ABI and paste it directly inside the code. The second thing we would need is the contract address. So from the Remix editor, when you deploy the contract, you can take the contract address from there, paste it, and then we need the address of the Ethereum accounts from which the transaction will be made. So from the Ethereum account address that we will be using, so this account address must be unlocked in the Go Ethereum client, and then we would be using another argument, which is gas price. We will be setting the gas price. It will be set to 20 GWEI, so 20 gigawatt. So gas price is set as that. Fine. So at this point, we have defined the deployed contract. Now we can just go ahead and execute it. So we need to either call store or read data. So let us first start with read data. So since it is a view, we will just do a call and then write dot then pass the function which just logs the output. Now to run that code, what we need to specify is what we need to do is we need to ensure that this Go Ethereum client is running, and then we can go ahead and execute that code. So it is doing a read data, so it will read the latest state from the ledger and give us the output of read data. So we can see that it is giving us 22. So if we go ahead and change something from the Remix editor, so we can just change it to some other value and do transact. So it will open a MetaMask and we can do a send transaction here. So let us wait for it to succeed. Okay, now it is successful. So we can go back to our code and execute it again to see that if the change is being reflected. We can see that the value is updated. Fine. So next what we can do is we can try to call store also. So instead of read data, we will do store and change this call to send, because we will be sending a transaction and we will be passing this input as 11. So let us now execute it. So what it will do is it will send a transaction to the Ethereum network. Therefore it will take much more time than the view, which was just one call. So it is sending the transaction and waiting for it to get mined. So once it is successful, you will get the output with details of the transaction hash, the block, etc. So it is successful now. To test it, you can go back to the Remix editor and then you can click read data and you will see that the value is updated to 11. So, we saw that we can use Web3 library for programmatically accessing smart contracts on Ethereum network. So, if some contract is deployed on the Ethereum network and you want to build some decentralized application with it, then you can develop that dApp using Web3 API, and you can use call and send for read and read and writes to the ledger data. So, concluding, we talked about how we can write Ethereum smart contracts, and we can use the Remix editor to write Solidity codes in it, test that code on a emulator which is provided within the Remix editor, and then we can also use this Remix editor and a tool called MetaMask to deploy this contract on a network, be it the main network or test networks. Then we also saw how we can use Web3.js to programmatically access decentralized applications using it. So, dApps actually are composed of a combination of both the smart contracts and the application code. The smart contracts will be developed with the Solidity language and deployed within the network, and the application will form the user interface that can be used by end users to interact with that contract, and this application will be developed using Web3.js. Now, at this point we have learned about all the tools required to build a decentralized application on the Ethereum platform. Thank you.